Welcome to AmeenAcademy.com. Let us go mini 2 on chemistry. That is summary of the subjects. Chemistry is the scientific study of the properties and behavior of matter. It is physical science under natural sciences that covers the elements that make up matter to the compounds and made of atoms, molecules, ions, their composition, structure, properties, behaviors, and the changes they undergo during a reaction with other substances. Chemistry also addresses the nature of chemical bonds in chemical compounds. The word chemistry comes from the modification during the Renaissance of the word alchemy, which referred to an earlier set of practices that encompassed elements of chemistry. The modern word alchemy in turn is derived from the Arabic word alchimia. This may have Egyptian origin since alchemia is derived from the ancient Greek. The current model of atomic structure is the quantum mechanical model. Traditional chemistry starts with the study of elementary particles, atoms, molecules, substances, metals, crystals, and other aggregates of matter. Matter. What is matter? Matter can be studied in solid, liquid as the plasma states, in isolation or in combination. The interactions, reactions, and transformations that are studied in chemistry are usually the result of interactions between atoms leading to rearrangements of the chemical bond, which holds atoms together. Such behaviors are studied in a chemistry laboratory. A chemical reaction is a transformation of some substances into one or more different substances. The basis of such a chemical transformation is the rearrangement of electrons in the chemical bond between atoms. It can be symbolically depicted through a chemical equation, which usually involves atoms as subject. The number of atoms on the left and the right in the equation for a chemical transformation is equal. When the number of atoms on either side is unequal, the transformation is referred to as nuclear reaction or radioactive decay. Here are some example of chemical equation, that is 2H2 plus O2 gives 2H2O. This side is a reactant, this side is a product. The type of chemical reactions a substance may undergo and the energy changes that may accompany it are constrained by certain basic rules known as chemical laws. Energy and entropy consideration are invariably important in almost all chemical studies. Chemical substances are classified in terms of their structure, phase, as well as their chemical composition. Matter. What is matter? In chemistry, matter is defined as anything that has rest mass and volume, that is, it takes up space and is made up of particles. The particles that make up matter have rest mass as well. Not all particles have rest mass, such as the photon. Matter can be pure chemical substance or a mixture of substances. Next, atom. The atom is the basic unit of chemistry. It consists of a dense or core called the atomic nucleus, surrounded by a space occupied by an electron cloud. The nucleus is made up of positively charged protons and uncharged neutrons, together called nucleons, while the electron cloud consists of negatively charged electrons which orbit the nucleus. In a neutral atom, the negatively charged electrons balance out of positive charge of protons. The nucleus is dense. The mass of the nucleus is approximately 1836 times that of an electron. Yet the radius of an atom is about 10,000 times that of a nucleus. Here this periodic table of chemical elements. A chemical element is a pure substance which is composed of a single type of atom, characterized by a by its particular number of protons in the nuclei of its atom, known as the atomic number, and represented by the symbol Z. The mass number is the sum of the number of protons and neutrons in a nucleus. Although all the nuclei of all atoms belonging to one element will have the same atomic number, they may not necessarily have the same mass number. Atoms of an element which have different mass number are known as isotopes. For example, all atoms with 6 protons in their nuclei are atoms of the chemical element carbon, but atoms of the carbon may have mass numbers 12 and 13. These are isotopes of the carbon. Next, compound. A compound is a pure chemical substance composed of more than one element. The properties of a compound bear little similarity to those of its elements. Next, molecules. Molecule is the smallest indivisible portion of pure chemical substance that has its unique set of chemical properties. Molecules are typically a set of atoms bound together by covalent bonds, such that the structure is electrically neutral and all valence electrons are paired with other electrons, either in bonds or in lone pairs. Here is a molecular structure of benzene here, for example. The inert or noble gas elements, that is helium, neon, argon, krypton, xenon and radon, are composed of lone atoms as their smallest discrete unit. But the other isolated chemical elements consist of either molecules or networks of atoms bonded to each other in some way. Substance and mixture. A chemical substance is kind of matter with a definite composition and set of properties. A collection of substance is called a mixture. Examples of mixtures are air and alloys. Now, next we'll discuss about mole and amount of substance. The mole is a unit of measurements that denotes an amount of substance, also called chemical amount. 1 mole is defined to contain exactly 6.02214076 into 10 raised to 23 particles. This is also called Avogadro number. Atoms, molecules, ions and electrons, where the number of particles per mole is known as the Avogadro constant. Here, the phase. Here, there are 3 phases are there: solid, liquid, gas. So, solid to liquid, melting; liquid to gas, boiling or evaporation; and solid to directly the gas, its sublimation; and gas to solid, this deposition; gas to liquid is condensation; liquid to solid is freezing. A phase is a set of states of a chemical system that have similar bulk structural properties over a range of conditions such as pressure and temperature. The most familiar examples of phases are solid, liquid and gases. Many substances exhibit multiple solid phases. For example, there are 3 phases of solid, that is ion, that is alpha, gamma and delta, that vary based on temperature and pressure. Next, bonding. A chemical bond can be a covalent bond, an ionic bond, a hydrogen bond, or just because of van der Waals force. An ionic bond is formed when a metal loses one or more of its electron, becomes a positively charged cation, and the electron are then gained by one non-metal atom, becoming a negatively charged anion. The 2 oppositely charged ions attract one another, and the ionic bond is the electrostatic force of attraction between them. For example, sodium, that is Na, a metal, loses one electron to become a sodium positive ion because it loses electron. Cation, while chlorine, that is Cl, a non-metal, gains this electron to become chlorine negative because it gained one electron. The ions are held together due to electrostatic attraction, and that compound, that is sodium chloride, normal salt, that is NaCl, or common table salt, is formed. Next, methane. In a covalent bond, one or more pairs of valence electron are shared by two atoms. The resulting electrically neutral group of bonded atom is termed a molecule. Atoms will share valence electron in such a way as to create a noble gas. Electron configuration, that is 8 electrons in their outermost shell for each atom. Here, this is the 8 valence electron surround the carbon and connect with hydrogen atom. Energy. In the context of chemistry, energy is an attribute of substance as a consequence of its atomic, molecular or aggregate structure. Since chemical transformation is accompanied by a change in one or more of these kinds of structure, it is invariably accompanied by an increase or decrease of energy of the substance involved. There exist only limited possible states of energy for electrons, atoms, and molecules. These are determined by the rules of quantum mechanics, which require quantization of energy of a bound system. The atoms, molecules in a higher energy states are said to be excited. The molecules, atoms of substance in an excited energy state are often much more reactive, that is, more amenable to chemical reactions. The transfer of energy from one chemical substance to another depends on the size of energy quanta emitted from one substance. The existence of characteristics energy levels for different chemical substances is useful for their identification by the analysis of spectral lines. The different kinds of spectra are often used in chemical spectroscopy, that is IR, microwave, NMR, ESR, etc. Spectroscopy is also used to identify the composition of remote objects like stars and distant galaxies by analyzing their radiation spectra. The term chemical energy is often used to indicate the potential of a chemical substance to undergo a transformation through a chemical reaction or to transform other chemical substances. Next, we will discuss about reaction. When a chemical substance is transformed as a result of its interaction with another substance or with energy, a chemical reaction is said to have occurred. A chemical reaction is therefore a concept related to the reaction of a substance when it comes in close contact with another, whether as a mixture or a solution, exposure to some from the form of energy or both. It results in some energy exchange between the constituent of reaction as well as with the system environment, which may be designed vessels, often laboratory glassware. Chemical reactions can result in the formation of dissociation of molecules, that is, molecules breaking apart from two or more molecules or rearrangements of atoms within or across molecules. The sequence of steps in which the reorganization of chemical bonds may be taking place in the course of a chemical reaction is called its mechanism. Ions and salts. An ion is a charged species, an atom or molecule that has lost or gained one or more electrons. When an atom loses an electron and thus has more protons than electrons, the atom is positively charged ion or cation. When an atom gains an electron and thus more electrons than protons, the atom is negatively charged ion. It's called anion. Cation and anions can form a crystalline lattice of neutral salts such as Na plus and Cl minus ions forming sodium chloride or NaCl. Example of polyatomic ions that do not split up during acid-base reaction are hydroxide and phosphate. Plasma is composed of gaseous matter that has been completely ionized, usually through high temperature. Acidity and basicity. A substance can often be classified as acid or base. Acids are substances that donate a positive hydrogen ion to another substance in a chemical reaction by extension. A base is the substance which receives that hydrogen ion. Next, redox. Redox, that is reduction oxidation reaction, include all chemical reaction in which atoms have their oxidation states changed by either gaining electrons, that is reduction, or losing electrons, that is oxidation. Substances that have the ability to oxidize other substances are said to be oxidative and are known as oxidizing agents. Oxidants are oxidizers. An oxidant removes electrons from another substance. Similarly, substances that have the ability to reduce other substances are said to be reductive and are known as reducing agents, that is reductants or reducers. Equilibrium. A system of chemical substances at equilibrium, even though having an unchanging composition, is most often not static. Molecules of the substances continue to react with one another, thus giving rise to dynamic equilibrium. Thus, the concept describes the state in which the parameters such as chemical composition remain unchanged over time. Now let us discuss some chemical laws. Chemical reactions are governed by certain laws which have become fundamental concepts in chemistry. Some of them are here. Avogadro law. Avogadro law states that equal volumes of all gases at the same temperature and pressure have same number of molecules. Beer-Lambert law. Attenuation of light to the properties of the material through which the light is traveling. Boyle's law. The absolute pressure exerted by a given mass of an ideal gas is inversely proportional to the volume it occupies if the temperature and amount of gas remains unchanged within closed system. Charles' law. When the pressure on a sample of a dry gas is held constant, the Kelvin temperature and the volume will be in direct proportions. Fick's law of diffusion. Fick's first law relates the diffusive flux to the gradient of the concentration. It postulates that the flux goes from region of high concentration to regions of low concentration with a magnitude that is proportional to the concentration gradient, that is spatial derivatives, or in simplistic terms of concept that a solute will move from a region of high concentration to a region of low concentration across a concentration gradient. Gay-Lussac law relating pressure and temperature. The ratio between the volumes of the reactant gases and the gaseous products can be expressed in a simple whole numbers. Le Chatelier's principle. When a simple system in thermodynamic equilibrium is subjected to a change in concentration, temperature, volume or pressure, the system changes to a new equilibrium. Then this change change partly counteracts the applied change. Henry's law. Henry's law is a gas law that states that the amount of dissolved gas in a liquid is directly proportional to its partial pressure above the liquid. Hess law. Enthalpy of a chemical process is independent of the path taken from the initial to the final state, that is, enthalpy is a state function. Law of conservation of energy leads to the important concept of equilibrium, thermodynamics and kinetics. Law of conservation of energy states that the total energy of an isolated system remains constant. It is said to be conserved over time. Law of conservation of mass continues to be served in isolated system even in modern physics. However, special relativity shows that due to mass energy equivalence, whenever non-material energy, that is heat, light, kinetic energy, is removed from a non-isolated system, some mass will be lost with it. High energy losses result in loss of variable amounts of mass, an important topic in nuclear chemistry. Law of definite composition. Although in many systems, notably macromolecules and minerals, the ratios tends to be require large numbers and are frequently represented as a fraction. Law of definite proportions, sometimes called Prost's law. A law of constant composition states that a given chemical compound always contains its component element in fixed ratio by mass and does not depend on its source and method of preparation. Law of multiple proportions. Law of multiple proportions states that if two elements form more than one compound, then the ratios of the masses of the second element which combine with a fixed mass of first element will always be ratio of small whole numbers. This law is known as Dalton's law. Raoult's law. It states that the partial pressure of each components of an ideal mixture of liquid is equal to the vapor pressure of the pure component, that is liquid or solid, multiplied by its mole fraction in the mixture. In consequence, the relative lowering of vapor pressure of a dilute solution of non-volatile solute is equal to the mole fraction of solute in the solution. Subdiscipline in chemistry. Chemistry is typically divided into several major subdisciplines. There are also several main cross-disciplinary and more specialized fields of chemistry. Analytical chemistry is the analysis of materials samples to gain an understanding of their chemical composition and structure. Analytical chemistry incorporates standardized experimental methods in chemistry. This method may be used in all subdisciplines of chemistry, including purely theoretical chemistry. Biochemistry is the study of the chemicals, chemical reactions and interaction that takes place in living organisms. Biochemistry and organic chemistry are closely related, as in medical chemistry or neurochemistry. Biochemistry is also associated with molecular biology and genetics. Inorganic chemistry is the study of the properties and reactions of inorganic compounds. The distinction between organic and inorganic disciplines is not absolute and there is much overlap, most importantly in the subdiscipline of organometallic chemistry. Materials chemistry is the preparation, characterization and understanding of substances with a useful function. The field is now breadth of study in graduate programs and it integrates Elements from all classical areas of chemistry with a focus of fundamental issues that are unique to materials. Primary system of study includes the chemistry of condensed phases, that is solid liquid polymers, and interfaces between different phases. Neurochemistry is the study of neurochemicals including transmitters, peptides, proteins, lipids, sugars, and nucleic acids, their interaction, and the roles they play in forming, maintaining, and modifying the nervous system. Nuclear chemistry is the study of how subatomic particles come together and make nuclei. Modern transmutation is a large component of nuclear chemistry, and the table of nuclides is an important result and tool for this field. Organic chemistry is the study of the structure, properties, composition, mechanisms, and reaction of organic compounds. An organic compound is defined as any compound based on a carbon skeleton. Physical chemistry is the study of the physical and fundamental basis of chemical system and processes. In particular, the energetic and dynamics of such systems and processes are of interest to physical chemists. Important areas of study includes chemical thermodynamics, chemical kinetics, electrochemistry, statistical mechanics, spectroscopy, and more recently astronochemistry. Physical chemistry has large overlap with molecular physics. Physical chemistry involves the use of infinitesimal calculus in deriving equations. It is usually associated with quantum chemistry and theoretical chemistry. Physical chemistry is a distinct discipline from chemical physics, but again there is very strong overlap. Theoretical chemistry is the study of chemistry via fundamental theoretical reasoning, usually within mathematics or physics. In particular, the application of quantum mechanics to chemistry is called quantum chemistry. Since the end of the Second World War, the development of computers has allowed to systematic development of computational chemistry, which is the art of developing and applying computer program for solving chemical problems. Theoretical chemistry has large overlap with theoretical and experimental condensed matter physics and molecular physics. Other subdivisions include electrochemistry, femtochemistry, flavor chemistry, flow chemistry, immunohistochemistry, hydrogenation chemistry, mathematical chemistry, molecular mechanics, natural product chemistry, organometallic chemistry, petrochemistry, photochemistry, physical organic chemistry, polymer chemistry, radiochemistry, sonochemistry, supramolecular chemistry, synthetic chemistry, and more. Interdisciplinary fields include agrochemistry, astrochemistry, like these are more varieties of chemistry field. Chemical industries. The chemical industry comprises the companies that produces industrial chemicals. Central to the modern world economy, it covers raw materials like oil, natural gas, air, water, metals, and minerals into more than 70,000 different products. The plastic industry contains some overlap, as some chemical companies produce plastic as well as chemicals. Various professionals are involved in the chemical industry, including chemical engineers, chemists, and lab technicians. The chemical industry represents an important economic activity worldwide. The global top 50 chemical producers in 2013 had sales of $980.5 billion with a profit margin of 10.3%. Here, the professional societies regarding chemistry American Chemical Society, American Society for Neurochemistry, Chemical Institute of Canada, Chemical Society of Peru, like this World Association regarding chemistry field. Thanks for Wikipedia. If you have done, please subscribe our YouTube channel.